Hello, good day viewers. Still on mathematical induction. In this tutorial, we want to prove that the summation of r squared, r from 1 to n, is exactly the same as n multiplied by n plus 1 multiplied by 2n plus 1 divided by 6 for all n in the set of real numbers. Okay, as you all know, we have three basic steps. The first step is to test for n equal to 1 to see whether the left and the right hand side are exactly the same. So let's start. So step 1, we want to test for n equal to 1. Therefore, we have summation of r squared, r from 1 to 1, which is equal to 1 multiplied by 1 plus 1 multiplied by 2 multiplied by 1 plus 1 divided by 6. We have just substituted n equal to 1 from left to right. So from the left hand side, we have a single term 1 squared, substituting r equal to 1. And to the right hand side, we have, from this bracket, we have 1 plus 1 equal to 2. From this bracket, we have 2 times 1, 2 plus 1, 3. And we have 1 outside here. 1 times 2 times 3 is 6, divided by 6. To the left hand side, we have 1 squared 1. And to the right hand side, we have 6 divided by 6 equal to 1. So we have seen that 1 is true in the set of real numbers. So in the second step, we want to also assume a certain value in the set of real numbers will be true. So we are going to set n equal to k, for which k belongs to the set of real numbers. So second step, step 2, we want to assume n equal to k is true. So what we have is the summation of r squared, r from 1 to k this time around. And this is equal to, remember, to the right hand side we have n, but we are going to replace it with k multiplied by n plus 1, k plus 1, multiplied by 2n plus 1, 2k plus 1. All of this divided by 6. So we want to assume that this is true. Before we continue, let me break this down. Remember, summation means you should be adding series of this, substituting r equal to 1 after k. So we have the first term 1 squared, the second term 2 squared, the third term 3 squared, plus you keep on adding these terms after the last term k squared, and it will still be equal to k multiplied by k plus 1 multiplied by 2k plus 1, or divided by 6. So we want to assume that this statement is true. So if it is true, in the last step, we want to prove k plus 1 will also be true. What does that mean? It means any value you take in the set of real numbers, if it is true, the next term will also be true. If 6 is true, 7 will be true. That is what it means. So step 3, we want to prove that n equal to k plus 1 is true. So we're going to have a summation r squared, r from 1 to k plus 1. And this is equal to, wherever we have n, we are going to substitute it with k plus 1. So we have k plus 1 multiplied by n plus 1, that is k plus 1 also plus 1. Then we multiplied by 2n plus 1, that is 2 multiplied by k plus 1, for which k plus 1 is equal to n plus 1. The whole of this divided by 6. Let me first of all simplify the right hand side before coming back to the left hand side. The right hand side, from here you can see we have 1 plus 1 equal to 2, right? So we have k plus 1 multiplied by k plus 2, right? And the other factor, if you distribute 2 here, you're going to obtain 2k plus 2 plus 1, that is 2k plus 3. 2k plus 3. The whole of this divide by 6. So this is what we have to the right hand side. Now let us simplify the left hand side and see whether we're going to get the same thing. What we have to the left hand side is the summation of r squared, r from 1 to k plus 1. If you expand this, you're going to get 1 squared plus 2 squared plus. If you keep adding these terms, you're going to get to the last term, which is k plus 1 all squared. But remember that the term before the last term is k, because k plus 1 is the next term after k. So we can add it here, k squared. One thing you should observe is that we have this previously, which is exactly equal to the right hand side here. K multiplied by k plus 1 multiplied by 2k plus 1 divided by 6, which we are going to replace here, but we still have another term, which is k plus 1 all squared. K plus 1 all squared. To rationalize it, you can divide it by 6 and multiply it by 6 just to have common denominators. Now let us add the numerators together. This will give us k multiplied by k plus 1 multiplied by 2k plus 1, then plus 6 multiplied by k plus 1 all squared. The whole of this divided by 6. Now what we have to the top can be factorized because we have k plus 1 in common. So let's bring it out. If you bring k plus 1 outside, inside we're going to have k multiplied by 2k plus 1 left from the left hand side. If you multiply k by 2k, you're going to obtain 2k squared. K multiplied by 1 will give us k. And to the other term, you know this is double, 1 is already out. We have k plus 1 left multiplied by 6. 6 times k will give us 6k. 6 times 1 will give us 6. Remember, the whole of this should be divided by 6. If you further break it down, you have k plus 1 multiplied by 2k squared plus 7k, then plus 6. The whole of this divided by 6. The quadratic expression here can be factorized. We're going to take the leading coefficient here and multiply by 6, which is equal to 12. Then we think of two numbers which can be multiplied together to get 12 and add together to get the coefficient of k, which is 7. The numbers are 4 and 3. But since the leading coefficient is 2, we have to divide them by 2. So these are the numbers we need. We're going to get 2 and 3 divided by 2. Okay, let's break it down. This is equal to k plus 1 multiplied by k plus 2 multiplied by k plus 3 divided by 2. But more conveniently, we can multiply this and this by 2 so that we have 2k plus 3. So we have 2k plus 3. The whole of this divided by 6. So this is what we have to the left hand side. But let us relate it to what we have to the right hand side and see whether they are the same. Remember that this is what we have to the right hand side, k plus 1 multiplied by k plus 2 multiplied by 2k plus 3 divided by 6. And you can see they are exactly the same. So we conclude, since the left and the right hand side are the same, we conclude that the statement is true, right? It's true for all n in the set of real numbers. And this is all I have for you today. Thank you for watching. Do share to your learning colleagues and don't forget to subscribe to my YouTube channel for more exciting videos. Bye bye.